Lesson 4.3.2, more with the unit circle. We are focusing on, we're going to start using that chart. Okay, so you'll want to have that chart, be working on knowing it or flipping back and forth to it, whatever the case is. But we are looking at finding the value of trig functions wherever they are. So we already know, based on our chart, the value of trig functions at 30 degrees, 45 degrees, and 60 degrees, correct? And what we're going to look at is applying that of, okay, what if I need to know the value of my trig functions at 150 degrees? Okay, I don't have 150 degrees on that chart. And so remember we talked last week about reference angles? How a reference angle is the angle it makes on the x-axis at the origin, right? And you add or subtract from 180 or 360. We're using those, and we're using our chart, and we're using our saying of all students take calculus, or what we know about the quadrants, to put it all together. So if you look up top there's kind of a set of 4 steps, and I'll kind of talk you through those steps, especially when we get started. But the first thing we're going to do in these problems is we're going to figure out the reference angle of the given angle. So, if I give you 150 degrees, we're going to figure out how far is that from the x-axis. The second thing we're going to do is we're going to talk about what quadrant it's in. Okay, is it in quadrant 1, 2, 3, or 4? We'll practice that. And then the third thing we're going to do is we're going to write out the answers based on the reference angle. So for 150 degrees, that is 30 degrees from the x-axis. So we would write out our answers for 30 degrees from our chart. And then the fourth thing we're going to do is we're going to put the signs on it. So using our all students take calculus, we're going to put the correct positive or negative signs on it. So we looked at this a little bit back in 4.3.1, but we didn't use this technique. We're trying to streamline it, okay? So, example 1 to get us started. Find these 6 trigonometric functions of 315 degrees. And keep in mind, I am looking for non-calculator answers. So this is not plug it into the calculator and give me some lovely, crazy, messy decimal. That's not what I'm looking for, and that won't get you credit either. Okay? I'm looking for, what is this according to our chart? Using our answers like 1/2, square root of 3 over 2, square root of 2 over 2, things like that. Okay, so if I go based on steps. Step 1 says to find the reference angle. And keep in mind, a reference angle is always between what and what? A reference angle always has to be able to land within the first quadrant. So a reference angle is always between 0 and 90 degrees. So, what can you visualize about 315 degrees? Okay, so yeah, if you think about 315 degrees, you're at least getting to start off with degrees. Can you visualize where 315 degrees is? It's somewhere down here, correct? And this is one where you might want to have your circle out. Yes.
Is everything we changed on?
And we'll add stuff as we go, but no, we haven't really changed anything. Okay, guys, so 315 degrees. You can visualize that it's going to be down here in quadrant 4 shortly before you get to 360, right? So if I want the reference angle, what do I do with that? I'm going to subtract those two, yes? Because it's closer to 360 than it is 180. So to get this reference angle, 360 minus 315, and Ross already said that was 45 degrees. So as we work this problem, we're no longer going to think about it as 315 degrees. We're going to think about, okay, it's equivalent to a 45-degree angle. Okay, if you look up above, suppose it's step 2, and I've already mentioned it. We kind of do step 1 and step 2 together, if you ask me. What quadrant is 315 degrees in? That's in quadrant 4, yes?
It's not there, okay?
Okay. Step 3.
Right out.
Yeah, I guess. Okay. So we're going to write out our 6 answers. Now, even though it says 315 degrees, I'm not using 315 degrees. What am I going to think? 45. We're going to think 45 degrees. Because 45 degrees is our reference angle. Okay? And I guess I should have drawn a better picture down here. I didn't look at my notes what I've done in the past, but if I draw a little bit larger picture, I don't know how well you guys could see that picture, but 315 degrees is down here. It's closest to 360 degrees, and those are 45 degrees apart when we subtract them, yes? So that's the idea of what I was doing there. So if you need a little bit bigger picture to visualize. Okay, so because 315 is 45 degrees from 360, we're using 45. I don't want to calculate your answers. Go back to your chart. You know that chart you're supposed to be working on memorizing. That's what we're using. So I'm going to say, what is the sine of 315 degrees? But when I say, what is the sine of 315 degrees, you're going to think 45 degrees. So what is the sine of 315 degrees, aka 45 degrees?
Negative. No, the chart.
Okay, I'm not going to talk negative yet, but okay, so square root of 2 over 2. And this goes back to our chart, right? Now, the chart from what lesson? We first did it
4.2.
in 4.2.2. We redid it in 4.2.3. And we're going to quiz on it Thursday or Friday if we don't get to it on Thursday.
So,
yes.
There's like an or, like for this one especially, like it's either a square root of 2 over 2 or 1 over square root of 2. You'll think both, right?
I will.
Okay.
Yeah. I tend to write square root of 2 over 2, but it is good to know that it's 1 over square root of 2. Now, if you're sitting there saying, yeah, I don't have this chart memorized yet, Mrs. Sargent, which I'm expecting most of you don't, could you also draw a triangle? Do you have your triangle memorized? Special right triangles.
What would it use? Whatever that.
Okay, so you can think about a 45, 45 right triangle. Yes, 45, 45, 90. What do we know about the legs in a 45, 45, 90?
They're 1.
They're ones. And what about the hypotenuse? Square root of 2. And so you can either memorize the chart or you can think SOHCAHTOA.
Because it's the hypotenuse is square root of 2 times. Is it one leg or both legs?
Times a leg. Yep. So sine, we would write 1 over square root of 2, but when you rationalize that, it's square root of 2 over 2, yes? Okay, what's cosine of 315 degrees? Square root of 2 over 2. In other words, what I was really saying is what's cosine of 45, right? What's tangent of 315 degrees?
1.
Or in other words, tangent of 45 is 1. That's because you're doing opposite over adjacent, 1 over 1. Okay. It said 6 trig functions, right? So which function, I keep practicing this with you guys, is the reciprocal of sine?
Yes.
Cosecant. CSC
I can't pronounce it.
of 315 degrees. Hey, on the test or quiz, he just has to be able to recognize CSC most likely. So, and what is our cosecant there?
Square root of 2.
Okay, and this is where I would go back and think, okay, sine was technically 1 over square root of 2.
Yeah.
So the reciprocal is square root of 2.
But can we write it as like 2 over the square root of 2? You don't like it, right?
Exactly.
Okay.
You can write it as like 2 over square root of 2,
It's
but
not the proper form, right?
it's not, yeah, it's not good
You
form.
can have a square root over.
Okay, what's the reciprocal function of cosine? Secant, SEC. So the secant of 315 degrees,
Square root of 2.
square root of 2. And what's the reciprocal of tangent? Cotangent, which is 1. Okay. Now, my official step 4. Put the proper signs in front of the answers based on the quadrant. So if you want to talk about an official step 4, what do we remember? What's our saying? All students take calculus. Or I guess you could put it over here if you want. All students take calculus. Which quadrant are we in? Quadrant 4.
Are we doing it for every single function? Every plus minus?
Well, so yeah, so now we have to go through and put in which one, we have to note which ones are positive, which ones are negative. So C represents cosine. So what is positive in quadrant 4? Cosine is positive in quadrant 4. And of course, if cosine is positive, then secant is positive. What about everybody else? They're negative. So now you need to go through and put negative signs on sine, tangent, cosecant, and cotangent. Now, one of the Cassies over there, when they gave me the first answer, they said negative on it. Could you go through and put your signs on it when you go through the first time? Yeah, and as you get better, I think you will. You're not going to want to have to go back and think, okay, now which ones are negative? If I'm going by the steps, though, that's officially step 4, which is what I was trying to show. Okay. Questions at this point? This is a huge thing, guys. Huge thing, being able to work with these angles that are outside of the first quadrant, how we get them equivalent to something in the first quadrant. Okay, so this is kind of putting all these steps together. Ready to try some other examples then? Okay, now, on that one, they had us do all 6, right? What's more than likely is you're just going to be doing one at a time. So, like, when we get down here to A, we're going to be doing sine of negative 210. So we're going to go through all those steps, but then we're only going to come up with a sine answer. Okay? So, negative 210 degrees. Where is negative 210 degrees? It's what? Negative 210 degrees is not in the third quadrant. Okay, so, and I'm going to teach this a couple different ways. So, officially, in the quadrant 3 answer came because you guys are thinking positive, right? Officially, if I start here at 0, and I go around the circle, here's 180, 210 is down here, right? That's a positive 210. To get to negative 210, that means we start here at 0, but we go down. So here's negative 90, negative 180, negative 210 is going to be here, up here. Okay, now, for those of you like, yeah, I don't like messing with this negative angle, John. How do we convert negative 210 into something better?
We have 16 minus.
Yeah.
Or I mean like plus.
Yeah. If you're sitting there thinking, oh gosh, I can't do that. I can't do negatives. It just, So here's my other recommendation. And some of you aren't going to do this. You're going to figure it out on your own. But take negative 210 and add 360. And so what we're finding is a coterminal angle. We're finding another name for the same angle in that quadrant. Negative 210 plus 360 is 150 degrees. If you were struggling with negative 210, can you visualize 150 better? Because that's who this is for. Because now if I say positive 150, can you find that pretty easily? Boom, right? It's there. Now, is 150 a reference angle? Is it in quadrant 1? And I can use my chart with 30, 45, and 60 on it. No. So now we need to find a reference angle with it. Okay, visualize that 150. I just showed it to you. Where is 150 closest to? Which part of the x-axis? It's closest to 180, isn't it? So how do I find that reference angle? Yeah. 180 minus 150 is 30.
Now I'm confused.
Okay. What I'm trying to do is I'm trying to get to a point where I can use my chart. So all of these today should come up with 30, 45, or 60. When I say 150, 150 isn't on that chart that we're memorizing. That chart has 30, 45, and 60. So everything I should do should fall into 30, 45, or 60.
Might always be 30, 60, or 45.
For this, within this section, yes. Okay? I'm not saying that everything will always equal 30, 45, or 60, but on this, when your design is to not use a calculator, to just use the XY chart, use our trig reference chart, that's the design. Okay? So now what we're going to do is we're going to think the sine of 30 degrees, but we're going to think sine of 30 degrees in what quadrant? Because negative 210 or positive 150 was in quadrant 2, yes? So what I need you to think is sine of 30, and then decide is it positive or negative based on what you know about quadrant 2. So first of all, according to our chart, what is the sine of 30? A half. Okay, so it's a half. What do we know about sine in quadrant 2? All students take calculus. Sine is positive in quadrant 2, so what do we know about the sine of negative 210? It's positive.
Also, when it's positive because it's right on.
It's positive because 150 is in the second quadrant, which is sine.
Yeah. But I thought we had to use like the chart.
You use the chart to get your number value. You use which quadrant it's in to get the positive or negative value.
So we still would have to get 150.
Well, after we found this 30, so step 1 was we found that this negative 210, remember I showed you on here that negative 210 ended up taking me, here's negative 180, it would take me up here. How far is that from the x-axis? And it was 30 degrees from the x-axis. So when we go to our chart, we're thinking 30.
Yeah.
But then notice it wasn't actually in quadrant 1 like 30.
Yeah.
It was in quadrant 2. And so then all students, so this is positive now. Okay? And so all of that to say, answer is positive 1/2. Questions I can answer. Okay. Let's try B. And we are going to keep it in radians. As much as you guys hate me right now, we're going to keep it in radians. Okay, so tangent of 5 pi over 3. Let's put you guys over here for right now because you guys might need this too. I don't really have room to put this in the notes, but I know some of you need this because the big thing we have to figure out is where this is. We're going to have to figure out what quadrant 5 pi over 3 is. Now, I guess I'm making this more difficult than what it is. You guys are just looking at your unit circle, aren't you?
It's on there.
Okay.
I think you don't have to draw it.
I'm still going to draw it for a moment because do you always have the unit circle? Or is it always one that's listed on the unit circle? Like the other day when we had, what was it, 8ths or 7ths? And your guy's like, oh, I can't do it. Okay. So this is 0. This is pi. This is also 2 pi, correct? If we're trying to figure out, what was it? 5 pi over 3? What do you need to think in terms of? We need to think in terms of these being thirds, yes? So 1 pi is 3 pi over 3. What is 2 pi? 6 pi over 3. And we are still going to have to talk about this. Where does 5 pi over 3 fall based on that information? What's 5 pi over 3 closest to? 6, yes? 5 is closer to 6 than it is to 3. So I know that 5 pi over 3 is somewhere in here. So the question becomes, what is the reference angle? How do I find my reference angle? We want to know this distance, right? So I'm going to take 6 pi over 3 and subtract 5 pi over 3. What is 6 pi over 3 minus 5 pi over 3? 1 pi over 3. So what is my reference angle that's on my chart? Just the 1 pi over 3. Okay? And, sorry, that didn't come out very readable there. Back over here. That is me teaching it like, okay, you don't always have a unit circle in front of you. You have to know how to, do the math here. Now, what some of you already did is some of you already said, boom, Mrs. Sargent, you're making it way too difficult. Okay. It's 5 pi over 3, right? I have to teach the math behind it. I do. Okay. So this is 5 pi over 3. We still have to figure out, it's obviously in quadrant 4, right? We still have to figure out what that angle is. And so that's where you still have to think, okay, 2 pi minus 5 pi over 3. And that's why I did 6 pi over 3 minus 5 pi over 3. Am I explaining myself well enough here? I'm boring some of you, I'm losing others. That's what's happening. Okay. So I will write down that I did 6 pi over 3 minus 5 pi over 3, and I got 1 pi over 3. So that means, for the purpose of this problem, I am thinking tangent of pi over 3 in quadrant what? Quadrant 4. So that's what you're asking yourself to finish this problem. What is the tangent of pi over 3 with the appropriate sign from quadrant 4? So what, according to your chart, what is the tangent of pi over 3? Okay, it would be the same as tangent of 60, right? Which is square root of 3. What do we know about tangent in quadrant 4? All students take calculus. Cosine would be positive. Others are negative, so this is negative square root of 3.
I'm sorry, I forgot what time you get square root of 3.
Look at your chart. What is the tangent of pi over 3? I need to find my chart that I can flash up on the screen. I usually have one somewhere. Aha, here's one I can put up there. This is bigger than what you have in your notes, but this chart right here, that's the chart I keep referring to, right? Okay, so tangent, pi over 3, square root of 3. Does that answer any lingering questions, maybe? Okay, that's the chart I'm referring to. Okay, ready to try another one? Do you have a question?
No question.
No? Okay, let me know if you do. This is where you guys have to voice your questions if you're thinking, right? You can't go on just saying, I'm too quiet to ask, or no one else is thinking that I can't ask it.
Notice you wrote the negative sign in front of the square root.
Okay.
I thought you did not.
Okay, yep. And as I said, if you have something, ask, guys, because I will re-explain it as much as I can. Okay, C. Secant. We'll worry about that issue in a moment. I go straight for that angle. Negative 3 pi over 4. What are you thinking?
Is this a 45 triangle?
It is.
So since secant is like the reciprocal of cosine, could you do with that?
We are, but we have to get a reference angle first. Or maybe you just did that, and I just didn't really. Okay. Negative 3 pi over 4. We need to figure out what this angle is equivalent to and what quadrant it's in. If you want to deal with negatives, you can. Negative 3 pi over 4 takes me down this way, right? And I don't know if you guys realize it would stop me here at 5 pi over 4. Okay, it's kind of, if you think about, I don't know how you guys think about this. Up here, 3 pi over 4 positive is this way, right?
Yeah.
So the negative would be down here at 5 pi over 4. Now, mathematically, how do I do this? Take negative 3 pi over 4 and add what to get a positive number if you want it? Add 2 pi. So if I take negative 3 pi over 4 and I add 2 pi. What is 2 pi in terms of fourths? You guys agree? 8 pi over 4?
So why don't you do
Because we're trying to get it, we're looking for a coterminal angle. We're going to add once around the circle, kind of like adding 360 earlier. So 8 pi over 4 is our equivalence to 2 pi. Negative 3 pi over 4 plus 8 pi over 4 is 5 pi over 4. Say that again, virtual, what just happened? Okay. So I need to unconfuse. Okay. So, negative 3 pi over 4. Some of you are going to tell me, I don't know where the negative 3 pi over 4 is. And if you're telling me that, I'm going to say, okay, let's turn this to positives, because we all work with positives a lot better, right? And so, when we have a positive, to get, remember last week we talked coterminal angles. You can add or subtract, if we're working in degrees, we can add or subtract 360 however many times we need to, right? to get to a nice angle we know. Well, this isn't degrees though, so we can add or subtract 2 pi. What is 2 pi in terms of fourths? And 2 pi, 2 is 8 over 4. And so we can take negative 3 pi over 4, add 8 pi over 4, and now we are at 5 pi over 4. Which when I had the unit circle up a moment ago, I showed you guys that it would be equivalent to 5 pi over 4, yes? I mean 8 pi over 4? You're always adding 2 pi, but 2 pi is equivalent to 8 over 4. Because 2 as a fraction, 2 over 1, is equivalent to 8 fourths, 8 over 4. I was just trying to get a common denominator so that, since we're working in terms of fourths here. Are we caught up at that point? Now, as we look at our chart, okay, as we look at our chart here, 5 pi over 4 is not one of these angles, is it? We have pi over 6, pi over 4, and pi over 3. Ignore the other 2 rows on mine, okay? We have those 3 angles. We need it to be one of those reference angles. And so this is where you look at what quadrant is 5 pi over 4 in. And this is where I would say it is right past what? 5 pi over 4 is a little bit more than pi, yes? Because what is pi? What is 1 pi when we talk fourths? 1 pi is 4 fourths, right? And so when we talk, this is 4 fourths, and so 5 fourths would go a little bit past our 4 fourths. And so in order to find our reference angle to work with, we're going to take 5 fourths and we're going to subtract 4 fourths. And that's going to give us our reference angle of what we're going to think here. Because we're going to take this 5 fourths, and we're going to subtract 4 fourths. And we're subtracting that 4 fourths because that's what it was. It was closer to, is it closer to 1 pi or 2 pi? And it was closer to 1 pi. So 5 pi over 4 minus 4 pi over 4 is pi over 4. So all of that to say, when we do this problem, it says secant of negative 3 pi over 4. So we can use our chart. We're going to think secant of pi over 4, correct? Secant is not one that I memorize as easily. I reciprocal it. What is secant the reciprocal of? Cosine. So now what we're really doing is we're going to think cosine, the reciprocal of cosine of pi over 4. For me to write that as a step, I wrote cosine of pi over 4 to the negative 1. So cosine of pi over 4. What is cosine of pi over 4 on the chart? Okay. Square root of 2 over 2, or 1 over square root of 2, right? Cosine pi over 4. You can think of it as either one. But since we need the reciprocal, which one should I think of it as? 1 over square root of 2, and then the reciprocal of 1 over square root of 2 is square root of 2. So this is square root of 2 in quadrant what? whoops. I agree with quadrant 3. My ink pen did not just write that, but I do agree, I promise. Quadrant 3. And what do we know about quadrant 3 and cosine?
Negative.
All students take. Tangent's positive. Everybody else is negative. So this is going to be negative square root of 2. Okay. It took us longer to get through than I thought, but are you starting to see this a little bit?
Do you have homework?
You can start looking at the homework and trying them, or you can start looking at D, E, and F and trying those examples we're going to do in class, try and think ahead, but nothing's due tomorrow.
Isn't it like, okay, so when we're solving that up there, instead of doing like the 5 times over 4 minus 5 over 4, can I just find like the degree and then 360 minus like 250?
I would rather you work on practicing staying in radians, just because there are times when it's better to be in radians.
Okay.
Yeah. So I get it. It's a good, what I would say is it's a good way to check yourself.
Okay.
If you're feeling unsure, if you're like, I don't know, I would check yourself that way, but I would ask that you try, my suggestion is try it in radians first. Okay? Uh-huh.
Sergeant,
Yes.
question.
Yes.